Hello, my name is John Ramsey, and today I'm going to present on measuring airflow underground using an anemometer. Just as a brief introduction, I work as a mine engineer out at one of our local trona mines. A big part of my job is ventilation. I'm going to talk about air volumes and the importance in my field. To begin, mine airflow. Why is it important? So mine airflow or ventilation is critical to the removal of heat, gases, and dust in underground operations. Okay. In addition, there's a lot of federal and state regulations that have specific regulations on specific quantities of air that need to be at certain locations of the mine or scenarios. So it's critical that we're able to measure these volumes. Another thing that I'm going to mention in regards to mine airflow is cubic feet per minute. Okay, that's a very common unit for airflow. Okay, so cubic feet, you might have a good idea of that. It's a feet by feet by feet, and 1 cubic feet per minute is that 1 cube uh, passing through, say, a doorway every minute. Okay, so that's an easy way to kind of understand that CFM that I will reference later on in the presentation. So airflow is measured in so many different ways. For today's instance, I'm going to use a Davis 4-inch anemometer. I'll go in a little bit more specifics here in a little bit. Okay. So before we get underway on how to take an air reading, we're going to need some materials, and those are going to include an anemometer. And as I mentioned, there's a lot of different anemometers, but for this instance, we're going to talk specifically about the 4-inch Davis anemometer. And I have a quick little picture right off to the right of two right there. There's actually a low speed as well as a high speed on that right end. Also, there's a little stick that you can see at the bottom of that illustration, and that's just a handle. That's a way to kind of extend that anemometer from your hand. Some other items we're going to need is a stopwatch as well as a distance measuring device. You can use a disto, as I call them. It's just a laser distance device, or maybe a tape measure. The reason we're going to need that is to measure areas, and we're going to need to know the width and height of those areas for a air reading. And last but not least, calculator is just going to make our math a little bit easier, a little bit more accurate, and it's going to help us as we move along. So let's get to talking about taking the air reading. Okay, so important before I explain the process is let's talk about orientation of the anemometer when we take an air reading. Okay, so it's important to remember that the dial face is facing away incoming air. Okay, so when we take this air reading, that dial face should always be facing away from airflow. Okay. Also, it's important that we always reset the anemometer before beginning. To reset it, there's a small little switch off to the right that's spring-loaded and is shown by the arrow that will click and reset before getting underway. To start the anemometer, there's a little switch on the top that goes left and right. Okay, when it's on the right side, it is on. When it's on the left, it is off. It's important that we start or turn on the anemometer right as we start our stopwatch to keep track of the time. Also, let's always keep the anemometer perpendicular to airflow. For this quick orientation, I'm going to talk about taking airflow in something such as a door frame. Okay, we have air flowing through the door frame, and we want to measure how much it is. What we're going to do is reset and start an anemometer at 0 seconds and turn it on for exactly 60 seconds as we traverse across the doorway and letting the anemometer spin and measure the linear feet that passes of air passes through the anemometer. As our stopwatch reaches 60 seconds, we're going to efficiently turn off the anemometer, and then we will read the total value that it shows. So we ran through the motions of taking an anemometer reading, and now we're going to use that to find a volume, a CFM, a cubic feet per minute. Okay, and we're going to find that by taking the area of the section that we measured and multiplying that by the velocity that our anemometer produces. Okay, so it's important to remember that an anemometer produces a velocity unit. Okay, so time value is dependent on the length it takes to conduct the reading. I always suggest taking 60 seconds for most of my mine entries, or anything that's 10 to 40 feet wide. Okay. Next, we need to find out what is the area of the entry. Okay, it's important just for this sakes that we measure those in feet, and the area will be presented in a square feet unit measure. Okay, now let's multiply an area by a velocity to equal that CFM figure. I included a sample problem with an area that is 10 feet wide, 10 feet tall, and we're going to theoretically say that we got an anemometer reading of 500 feet over a 60-second interval. Okay, so our area is 10 by 10 equals 100 square feet. Our velocity was 500 feet by 60 seconds, or that equals 500 feet per minute. And then we're going to take that area times it by velocity. So 100 times 500 equals 50,000 cubic feet per minute. So that's it. That's our big summary. That's how we took an anemometer to calculate a CFM reading. And hopefully that wasn't too hard, and that you guys can all do it on your own. Thank you very much.